Hi everybody, today I'm going to show you about the triangle midsegment theorem. So we'll look at a few examples of just what a midsegment is. And any triangle, as you can see here, ABC, and then on the bottom here QRP, any triangle, no matter what type it is, has a midsegment. And each triangle has actually 3 midsegments. To do this, what you're going to do is find the midpoints of each side of your triangle. So we'll just kind of sketch it and estimate it. Looks like AC is about right there. CB, halfway through that line there. The midpoint is right there. And then the midpoint of AB is probably about right there. And we can then construct the midsegments. And there's actually 3 of them. To do that, what we're going to do is connect or join the midpoint of 2 sides. So we'll just join this midpoint here. We'll join this midpoint there. And we also have the other midpoints to join too, so it actually creates another triangle inside. So those 3 red lines that I've created are all midsegments. So we're going to take a look at just an example of what happens when you have a triangle and you're trying to find midsegments. So the first thing it says, find the midpoint of QR and label it A. We don't have to do all the formulas out for this, since they're pretty neat integer coordinates here. The vertical distance or the horizontal distance from Q to R is, let's see, looks like 6 units on the x-axis there. So halfway across there would be 3. And you can cut the vertical distance in half from 8 to 4 would be 2. So we're going to go basically over 3 and down 2. So over 3 and down 2, the midpoint would be right there. So we would call that A. And that point would be 3, 6. And we can do the same thing for the other segments. To find the midsegment of RP, the horizontal distance is 3 and the vertical distance is 4 between P and R. So cut those each in half. We'll go over 1.5 and up 2. There's the midsegment. We'll label that one. No, you know what? I did the wrong one. Well, we can label it C, I guess. But they wanted us to find QP. Sorry, so QP would be the other line segment I haven't done. That horizontal distance is 3, and the vertical distance from Q to P is 8. So half of 3 and 8 is 1.5 and 4. So we'll go over to 1.5 and up to 4. So there is midsegment, or midpoint B. So that would be, once again, the vertices 1.5 and 4. So we have those there. We've labeled them on there. And the next thing we want to do is, we've already done number 3, plot both of the midpoints and connect them. We just have to actually now connect them. So to do that, we'll connect A to B. And what we want to do is actually come up with, the next thing says come up with the slope of line AB. So for slope, we just have to do rise over run from B to A. And if you look in here, we would go up 2. The rise would be 2, and the run would be 1.5. So it would really be 2 over 1.5, and it's positive. But that's the kind of a weird fraction. Let's double that to get rid of the decimals there. Let's say it's over 4 or 4 over 3. That would be our slope for AB. But now we want to see if we can find the slope of PR. So PR are these blue dots here that I'll create. And we can find the slope of that line going up and over. The rise and the run would be 4 and 3. So we know the slope is actually 4/3. I should have wrote that in the other place here, 4/3. So what can you conclude about the midsegment of AB and PR? They both have slopes of 4/3. Or the slopes are the same. Another thing that you can conclude, if the slopes are the same, we know that AB is parallel to PR. And there's the lines on top. So that's what we figured out there, but now we're going to look at the length. And to do this, we'll use the Pythagorean Theorem. Because I've already drawn my slope triangles in there, we'll just use the Pythagorean Theorem to figure that out. So AB, we knew that vertical distance was just the triangle there, 2 squared plus 1.5 squared. Again, that was 2 there and 1.5 equals AB squared. And then for PR, we have 4 and 3, so 4 squared plus 3 squared. We're just using that blue right triangle that we created. 4 squared plus 3 squared equals PR squared. Okay, and that will give us, when we calculate each of these, I'll kind of save you a little bit of time here. When we all do that together there, square root of 6.25 is what that ends up being, which is 2.5. And then the other one, when we calculate that, that would be the square root of 25, which we know is 5. So what relationship does the length of the midsegments AB have with the length of side PR? Well, if we compare AB and PR, the length of AB, or we'll say midsegment AB, is half the length. Ooh, I spelled that completely wrong. Half the length of the longer side, the bottom side PR. So that's kind of what we realized, and this is going to happen every single time that when you have a midsegment, the smaller midsegment is half the distance, or half the length of the base, and it's also parallel. And just by looking at it, you can kind of see, and it's just estimation here, but those two segments there, AB is actually half of the bottom one there. So if we took that away, and it's going to be kind of hard to estimate, but if you can kind of see that we'd actually have two of those green segments to make the bottom part there. And it didn't quite work out, but with the big thickness of the highlighter, it didn't work out too well. So here's the triangle midsegment theorem. A midsegment of a triangle is parallel to a side of the triangle. So DE is the midsegment, and it's parallel to AC. And its length, the length of DE, is half the length of that opposite side there. So that's our triangle midsegment theorem. And today you're going to use, we'll do a few examples together to see how it all works, and you'll get lots of practice time to work on the properties of triangle midsegments. And eventually you'll even work on proofs of proving why the midsegment is half and parallel. Alright, so let's take a look at the next part here. Our first example problem, we have a triangle here, and if you notice the outside triangle, we've only drawn in two of the midsegments. The other one, which for sake of ease, we probably don't want to draw it in right now, but that red dotted line would be the other midsegment. And the red, or that whole inside triangle, is actually called, right here, is actually called the midsegment triangle. So we'll look at a couple examples here. So to find a few measurements, let's just go to the diagram and see what we can figure out. We know in a midsegment, or in a triangle, the midsegment is half the length of the base that it's opposite from. So we have this midsegment. We'll look at this one first. Okay. We know that it's half the length of the longer side. So that longer side, if its longer side is 46, this one is 23. But we also notice that since we're constructing midsegments, it comes from the midpoints of a side. So if HG, the top red side there, is 46, it divides the other two in half, so this is 23, and this is 23. So it's kind of just figuring out all the pieces to the puzzle here. Switching colors, I guess, this midsegment is the midsegment of HJ. So if it is 27, we can double it to get the length of HJ. So 2 times 27 gives us 54. Okay. Or we could just say that this is 27 and this is 27. So we know those measurements. Let's see if that helped us with anything. VX, we found that out. That's our red segment. That's 23. HJ is the long blue side on the outside there. That is 54. It was basically two midsegments added together. And then we know, we'll go down to XJ here. We figured that out. XJ is 27. And then we also have a little bit more that we know here. So let's try to figure out this angle measurement. Let me show you, clear this off a little bit. And let's kind of extend some lines to help us out here. We're trying to figure out VXJ. So VXJ goes between these lines, and we know that these lines are actually parallel because they're a midsegment. So if we know, we were trying to figure out VXJ, which is this angle right here. And we can look right across to this angle because those angles are corresponding because there's a transversal that's cut through. The transversal would be HJ. So we know that this angle is 92 degrees as well. So that's the first problem that we've kind of used properties of midsegments. The next part. We want to find each measure again, and again we have two midsegments shown. So this time I'll highlight them so we can kind of see that DE is a midsegment of RT, and DC is a midsegment of ST. And you can actually see I kind of chunked it off that SE and ET and DC all have the same measurements. So we can actually fill that in right now that SE is going to be 36, ET is going to be 36, and combined ST would be double 36, which is 72. And kind of going the other way, we can figure out this small green segment DE. That would be half of the larger one here. So 44, half of that is 22. So that helps us figure out a few things here. We know that ST is the big long red side, 72. DE is the short green side, 22. And then we have to figure out some angles. So we'll kind of look for some parallel relationships here. We know, the one angle we know right now is that this is 48. So we want to figure out DES. So DES is this angle right there. That little blue angle in there. We want to figure out DES. And we actually know that if we extend our red highlighted lines, these lines are parallel, okay? And the green transversal is going through here. So we once again have alternate interior angles. So that blue angle that we're trying to figure out is the same thing as the 48 degree angle. Those are alternate interior angles. So it's also 48 degrees. And it was alternate interior with EDC. Then we got to figure out RCD. So RCD is this angle down here. And actually it's kind of handy that I highlighted it in blue there still because it's actually the same measurement because we have our two green parallel lines and the red transversal going through. So those are alternate interior angles again. So it's also 48 degrees. So that was the same reason as above. Okay, so take a second here to try to see if you can figure out the next question or how we would set it up. Alright, so for this one here, it says PQ is a midsegment, so we know that PQ is half of RT, and we know it's parallel. But we're going to use our relationship about length here. So we know that if we double this PQ, we would get RT. So the first way you could solve it is do this equation, double PQ, which is x plus 9, and that gives you RT. The other way you could do it was you could take half of 4x minus 27, the big one, and that will give you the small one. But it's probably easier to solve the first one. So we'll go ahead and distribute. We get 2x plus 18 equals 4x minus 27. And when you do all this solving here, subtracting 2x, you get 18 equals 2x minus 27. You continue on there, you get 45 equals 2x. And x equals 22.5. But that's not one of our answers, that's just x. We want to figure out the length of RT. So to figure out RT, we would plug in 22.5 into that equation for RT, or that expression, and we would get D is the answer. So I'm just going to go through these pretty quickly and then let you have some time to practice today. The next one here is UVW, and M is the midpoint of VU. We have all this information, but we don't have a picture. So we need to come up with a picture. In this case, let's just draw a general triangle UVW. It doesn't really matter how you draw it, at least it doesn't matter yet, we'll see. M is the midpoint of VU, so that'd be right here. N is the midpoint of VW, so that would be right there. And which statement is true? So So we'll draw that mid-segment in there. We know a few things that are true, but it says VM and VN. VM and VN would be this one and this, and this one. We don't know those are equal by the triangle midsegment theorem. So we have MN and UV. That would be this one and this one. There's no relationship there. VU and 2VM. So VU would be this guy. And 2VM, so two of these guys. And that's actually true because VM is the midpoint of VU. So our answer there is actually H. That's the one that we want. Last one. XYZ is a midsegment triangle this time. Which one cannot be determined? Well, let's just plug in some things that we know. We know this midsegment is congruent to these sides, so these will both be 8. We know that 14 is the same thing as this because those are midpoints. We know 67 can be some angles as well. 67 is down here because they're corresponding. 67 is also over here because those are corresponding angles as well. So if we know here, we can figure out KL, that's this part right here. So that doesn't work. We've already got JY, which is 14. And the one that we aren't able to figure out is D, KZY. We can't figure that one out. We know that XZL is 67. So D is the answer there. Go ahead and use these types of questions to help you out with the homework questions that you have. Check the answers as you're working, and we will see you tomorrow. Thanks, guys.